Hi, good morning. I'm Alex Turkeltaub, CEO and co-founder of Roam. Welcome to the session on extracting meaning from language data in healthcare. I'm not entirely sure if this works correctly, but it does. Okay, perfect. A couple things. This is a session obviously involves two people. For the first part, I will talk a little bit about Roam and what we do, talk about trends in healthcare and unlocking the value of text data, how do you derive meaning from that data, and then obviously what the solution is and some customer case studies. Obviously we have a Q&A. The way we're going to run it is I'll speak, my partner Kyle will speak from AWS, and then we'll do a Q&A. If people have a burning need to ask an immediate question, we can probably accommodate, but it'd be ideal if you waited till the end of the session. Just to talk briefly about our mission. The mission at Roam is very simple but very hard to do. It's to empower healthcare companies to derive structured meaning from language data to improve healthcare for all. What does that mean in plain English? The vast majority of data about patients right now lives in language data. Well, what does that mean? It lives in electronic health records, where the doctor puts a bunch of notes about how a patient is performing. It lives in telemedicine interactions, which can be recorded. It lives in notes that nurses may take when they visit an older patient at home. It lives in emails and messages you might be sending to your doctor or other providers, and a variety. It lives in academic publications and other places. And the thing that's, I think for anyone who works in healthcare, almost every nuanced question about patients is really in the language data, because the structured data that's captured in a health record is primarily around what has been done and billed, but almost no history. And so the mission at Roam is, if we can unlock the value of this data and use it productively, that we could dramatically change the outcomes for patients and reduce costs for the healthcare system. Just a brief introduction. I'm again CEO and co-founder. My background is I know nothing about healthcare and even less about technology. My background was primarily in political science, McKinsey, law school, and then doing a different company on data in emerging markets. But we have a very strong technical team. My co-founder, Andrew Maas, was a PhD student at Stanford doing deep learning for image and speech recognition under Andrew Ng. Chris Potts, our co-chief scientist, is a professor at Stanford, probably the world's leading computational linguist, specializes in extracting meaning from the type of data that we interact with and we'll be talking about today. Our head of commercial, Lacan Wong, very typical for our company, software engineer from Stanford, bioinformatics, that was at Palantir running a big chunk of Palantir's healthcare business and moved into the commercial roles. And our head of product has a lot of background in healthcare, Evan Lin. Broadly, we're a small company. We have just over 50 people. The vast majority of them are technical for one simple reason, is that this is a really difficult problem to solve, and we'll get into a lot of details on why and how in a second. And then we have a scalable team of nurse annotators, which will become obvious as well, but obviously annotating health data is a big part of what we do. Just for a little bit of background on who's backed us, our primary backers is a venture firm called 8VC in Silicon Valley, founded by someone who co-founded Palantir. Stanford is an investor out of its endowment, a number of smaller funds. And then we have a number of individual investors and advisors who are extraordinarily interesting. We have a number of healthcare CEOs. So George Barrett, who used to run Cardinal Health, Bill George, a legendary CEO in the healthcare space, who used to run Medtronic, Joe Jimenez, who just stepped down as the CEO of Novartis, Mark McClellan is an advisor. Mark used to run CMS and the FDA, and a number of others. We also have folks like Dan Jarafsky, who's chairman of linguistics at Stanford, or Miran Sahami, who was very early at Google and is now at Stanford, and Rupert Murdoch is an investor in our business. But we have about 70 individual investors and a bunch of institutional ones. But in the end, I have to say, investors are important. We thank them for their money, but it's just table stakes, and you actually have to do something with that money. And I'm sure you all read the papers, and you've seen some companies in healthcare that have taken a lot of money and thrown it down the toilet. So with that, let's talk about what we actually do. There's three things that are happening in healthcare that make our company possible. So the very first is the rise of EHRs and the access to data in digitized form. So before Obamacare, independent of what one thinks about Obamacare, all of the data was largely in scribbled places. I think estimates are about 9% of it was digitized. Now about 96% of it is digitized. It is badly digitized. Some of it is in PDFs. The vast majority of the electronic health record systems don't talk to each other, even within one network. So the whole system is very screwed up, but at least it's digital and usable. And that creates, obviously, an ability for companies like ours to work with it. Number two, there's a shift to paying for outcomes. And I'll say in advance, I'm a very blunt person. So what you read in the papers about outcome-based care is largely a bunch of baloney. The deals that pharmaceutical companies are supposedly doing to be paid based on how their drugs are impacting patients almost never work out, and either are sort of window dressing, or they're for drugs that you're either going to live or die, and if you die, they give you your money back because they have no choice. But what is happening at a very large scale is a change in how payers are assuming risk. And this happens in a bunch of different places. So you have the Kaisers of the world and the sort of Kaiserization of healthcare, where you have ACOs, MCOs, integrated payer providers rising. You have things like Medicare Advantage. So you have companies like Humana that are becoming essentially the Kaiser of Medicare Advantage, where the government pays you a fixed fee per patient. You're seeing a rise of primary care facilities that are assuming risk for the patients they take on. And even for big companies like United Health Group, you're seeing a large amount of value-based payments for procedures following what Medicare has done. So if you get a knee replacement surgery or a variety of other surgeries, you get a fixed fee unless it has to, and if it has to be redone within a certain period of time, then you end up having to do it for free as a hospital and the payer eats the cost. And so there's a rise of paying for outcomes in a very different way, and that changes incentives in very creative ways. And I think the rise, one of the things for people who are old enough in this room, if you remember in 1994 when Hillary Clinton proposed her initial healthcare plan, for, again, not to debate the politics of it, but one of her visions was the rise of HMOs. And that essentially means that the person who's paying is also providing care. And in the grand scheme of things, one way or another, we're moving to that system, because when you separate those two things, you have a lot of perverse incentives to overspend. And then the third trend, and this is probably the most subtle, but in some ways the most important trend, is the rise of language data as a tool for capturing information. And what does that mean? IBM, who obviously built Watson, I'm not going to talk negatively about our competitors, but suffice it to say that Watson has done very poorly in the market. But one thing they've pointed out correctly is about 80% of the data in healthcare is in language data. Our clients at a major hospital system estimate that only 40% of the data about patients is in EHRs. The other 60% is all language data, and the data in the EHRs is vastly language data. But even more importantly, and I don't know if maybe there's a show of hands, is there anyone who's a doctor in the room or who's practiced? One of the things that's happened since the rise of electronic health records is they've actually reduced the productivity of doctors, because you spend all day typing stuff in and trying to figure out what you need to do to get paid. And it's clear that EHRs 2.0 are going to have automatic capturing technologies that'll capture those patient-doctor conversations. And I'll give you guys one quick anecdote. Chris Potts, who's our co-chief scientist at Stanford, did a study on speed dating. Not healthcare, speed dating, where I guess I've been married a long time, so I miss the speed dating phenomena. But you meet a bunch of people of the opposite sex, or maybe even the same sex, in a short period of time. And they mic'd up people in those conversations. And it turned out that the highest predictor of a second date was the relative volume of voices in the first 30 seconds and how often you interrupt each other. Which, if you think about it, makes sense, because it means you're having a conversation rather than someone who's just spacing out. Now think about healthcare. I have a 90-year-old grandmother. I know in the first 5 seconds of calling her on a daily basis whether she's having a good day or a bad day based on the tone of her voice. For people who suffer from mental illness, you can see by the change in the language they use. How are they progressing? Is dementia getting worse? Is Alzheimer's getting worse? And so if you could record patient-doctor conversations, not only would you increase the productivity of doctors, but you'd capture a lot more data about how the patient is progressing through a disease, early indicators of behavior, and so forth. And so these trends make our business possible. The other thing that's very important is that when you think about language data, and when you read about language data, most people talk about one simple thing, which is concept extraction. Does this patient suffer from disease X? And when people get a little bit more sophisticated, they start talking about concept extraction at a meta level. So if there's 12 different ways to describe a particular disease, do you suffer from that? But you can do much more interesting things. So sentiment and reasons. Why did the patient behave that way? And oftentimes you'll see things in health records that'll say, patient Alex needed a knee replacement surgery but chose to delay it for financial reasons as his son has just begun university. Things like that. Versus patient Alex has been struggling with alcoholism, which prevents him from doing rehab. Those are very nuanced differences for the same thing. Mental state. Every doctor in the world knows that if you're depressed or you suffer from mental illness, your chances of taking your drugs, of doing your therapy, of showing up to your next appointment are much lower. None of that data is captured in anywhere but the language data. Conditions and comorbidities. We have a client who's a very large insurer who they do not know if patients are missing kidneys because by the time they inherit the patient, they have no idea, unless they paid for it, if there was a procedure of that type done. Or there may be new diseases that rise. Let's say a disease like NASH, fatty liver disease, that wasn't diagnosed originally. They may be able to go back through those records and identify indicators that you need to be tested because you have a high probability of having that disease. Again, that type of stuff. Labs and clinical factors, everyone thinks labs are very easy. We work with 2 major laboratory companies, diagnostic companies. When you get a cholesterol test done, that's very straightforward. When you're getting a pathology report for melanoma, it actually is quite complicated because that pathologist could specify the size, the size of the tumor, why they did multiple analyses, excuse me. Not for melanoma, but for other tumors, the specific place and locus and aggressiveness of the tumor and other things. Care rationale, why did a doctor decide to do certain things? If you talk to a pharmaceutical company and you say to them, why does a patient in, let's say, multiple sclerosis choose your drug versus another drug? They have absolutely no idea. And the reason it mostly happens is a patient has side effects and the doctor switches them. But there may be a discussion, an intense discussion by the doctor about why they told the patient to switch. And lastly, perceptions of efficacy, patient satisfaction, and so forth. The main point here is that language data isn't who has heart failure, although that in and of itself is a difficult problem, but it's all of these other things. So we at Rome, we think we're very smart, but clearly we're not the first people to recognize that language data matters. Why is it that people haven't unlocked it? Well, I'll give you one cynical reason, which is that till the change to value-based care, nobody cared. If you had a particular disease and you had comorbidities we missed, and those comorbidities resulted in you coming back to the doctor, the hospital made more money. And the insurance companies, although they paid for that, their whole business model was to own you for 18 months and dump you on the next guy, because that's the average amount of time you had an insurance policy. And eventually, you all got dumped on Medicare. And if you're poor, you were in Medicaid to begin with, which means that nobody actually cared. But if I'm being paid $100,000 to insure Alex, if I can figure out how to keep you healthy, and I recognize that you not having transportation access prevents you from going to an appointment and results in you being in an emergency room costing me 40 grand, then I have a huge incentive to think about things. But in addition to that, unlocking the value of this data is very hard. So there's enormous clinical complexity to healthcare. What does that mean? Let's think about natural language processing in general. Restaurant reviews are a perfect example of where it works beautifully. You know that certain words always correlate to outcomes. If someone mentions the word bathroom in a restaurant review, it is always a bad review. Nobody says the food was terrible, the bathroom clean, I'm coming back. People either say the food was good, but the bathroom was disgusting, or the food sucked and the bathroom was filthy, I'm not coming back. In healthcare, it's not like that. There's a lot more nuance to what you're looking for. In addition to that, depending on what you're trying to predict, the same word will have different meaning. If we're trying to find a patient for a clinical trial who has certain specific comorbidities, we're not that interested in your mental state. But if we're trying to figure out if you're going to come, that very same patient with the same disease will show up to their next appointment, you're looking for very different and more nuanced things. You can also do things like looking at households. We know that if I'm an opioid addict and my wife gets a knee replacement and gets put on an opioid, the probability of her becoming an addict is much higher. And if we have children at home, as we do, the probability that those children will then have declining socioeconomic determinants of health, to put it mildly, is very high. But you need to look at a household, and usually households are insured by the same insurer, so they could do it, but nobody's done that. Number 2, fragmented data sources. Not to pick on Epic, but what they've done is criminal, because they've built a system that's completely closed, that was subsidized by our government to the tune of $36 billion, where it is purposefully built in a way that not only is not cloud-based, but allows hospitals to keep you away from cheaper options so that all the referrals are within a system. And as a result, the system is completely closed, and if you want to get a broad view of an individual patient, it is a real pain in the you-know-what. They never built a system that's interoperable, that allows you to say, I go to one doctor who uses Cerner, another doctor who uses Epic, why can't that all be pulled up? And they make it really difficult to put all that data into one scheme because doctors can adjust the schemes. And so pulling that data in and integrating is very hard. Third, I think this is obvious, accuracy and precision are imperative. Obviously, we're not predicting whether you like a restaurant or not. In the grand scheme of things, that's not a big problem. But if we're trying to predict who should be tested for NASH and we miss a patient, or we're trying to understand what the probability is that you will have a recurrent problem with heart or whatever it is, or come back to the hospital, that's a much bigger issue. And the last point here, and this is subtle, but a little bit, what's the right word? It's probably the most important thing here, but less obvious, which is that if you're going to do these analyses once, you can probably use a lot of tools that are built out there, including some that Amazon offers. So in their academic life, both Andrew and Chris, our co-chief scientists, will have done these analyses to predict whether a patient will get readmitted for a disease. And then we'll use one platform to do the annotation of the data, and another platform to build models, and a third platform to deploy those models, and they'll tinker with them. And that usually takes about 6 to 9 months. What Rome has done is built an integrated platform, because our view is that for the most part, our clients don't really know what they want up front. So if I'm trying to predict whether Alex Turkeltaub, who has heart failure, will be readmitted to the hospital, they'll decide what to look for and what's important, the so-called annotation scheme up front. And then when they predict whether I'm going to be readmitted or not, they may be inaccurate, and they have to go back and re-annotate, and then they have to rebuild other predictive models. And then when the model is deployed, this is another paradoxical thing in healthcare, models in healthcare will get worse over time, not better, because the underlying data will change. Hospitals will change procedures or guidelines, a new doctor will join the group, whatever. And so an integrated platform that allows you to do all of that at scale is critical. I'm going to run through this a little bit faster because I see that I'm going to run out of time and I have to hand it over to Kyle in about 10 minutes. This is an example, an idealized example of a health record. I won't belabor the point. The only thing that's important here is that a very small percentage of the data is structured. And that thing you see on the right that's probably exaggerated how small it is, but for the most part, what the insurer looks at and what people build predictive models on is that small bit. But you can actually annotate enormous amounts of complexity and pick enormous amounts of complexity. And all you really need to know is the stuff you see in the blue on the bottom is saying, we knew 3 or 4 things about patient Turkeltaub, and now we can know 50 or 100 things about patient Turkeltaub. And the analogy I always use with our clients is, if you had the world's leading economist sitting in front of you and you gave them 3 pieces of information about the San Francisco economy and you asked them to predict next year's growth, they really would do a pretty poor job. Whereas if you take a first-year graduate student and give them 100 pieces of information, they do a much better job. And this is really at its core what we're trying to do, is saying, here's a patient, you know a limited amount of things about them. If we could know a ton more, what would you be able to predict? And this is what this shows. And here, you're seeing at the top, those are sort of the basic factors, and at the bottom are the additional ones that one could glean. I won't belabor the point here because I want to get to some specific case studies, but the Rome platform in general, on the left side, this is really important, is how do we allow a client to articulate a very specific use case? What is it that they're trying to predict about a particular patient? Define what matters to predict that. Because again, if I'm predicting whether you're a candidate for a clinical trial versus whether you're going to be readmitted to a hospital versus whether you're going to show up to an appointment, I'm looking at different stuff, then how do I annotate the data, i.e. extract from the unstructured data enough structure to put it together with other structured information, and then build tools on top of that? And so if you want to think at a very simple level, you can stop looking at the slide, people, and look at me. I'll explain this very simply. There's 3 parts to what we do. We take your data, integrate it, and annotate it, which means we take all of the unstructured data and give it structure and combine it with structured data. Then number 2, we build a predictive model on top of that to predict what will happen to that patient. And then we deploy that model so that it can actually work in real time. And all of that is built on top of the Rome Health Knowledge Graph, which is the largest integration of all the publicly available data in healthcare, so that we can use that as a premise for everything we do. And I'll give one simple example. I've been harping on heart failure, but this is actually sort of absurd. If you go to a hospital system in America and you say to them, show me your heart failure patients, they cannot do that. Because all they can show you are the patients who have been coded as having heart failure. But there are going to be patients who have had heart failure, and they've had comorbidities that correlate to it, so they have a probability, or they have all the symptoms, or the doctor forgot to treat them for it, or they had heart failure at a previous hospital, but this hospital didn't see it. And so just identifying patients who have a certain condition is extraordinarily difficult. And it gets even harder if you start thinking about things like who has a particular type of cancer with a particular origination locus, with a particular genetic set of markers, and combine that with socioeconomic determinants. That's an extraordinarily hard problem. And so what the Rome Health Knowledge Graph does is, rather than creating a master ontology, it uses multiple different ontologies to figure out if Alex has heart failure, what are the comorbidities that correlate to it, what are the drugs that someone might be taking, so we get a proper pool of patients to analyze. So one other quick thing, and then case studies, and then I'll turn it over. Language matters to a lot of different stakeholders. And this is a very critical point for us as a business, because whether we're talking to hospitals, i.e. providers, insurers, life sciences companies, diagnostic companies, distributors, CROs, For all of them, the core problem I described earlier is the same. They build predictive models on a tiny percentage of the data. You can take that data and enrich it greatly, know hundreds of things about a patient instead of just a few, and then build much more accurate models. So I'll give you a couple of simple case studies. So one, this is the most prosaic thing in the world, and yet so complicated. A primary care provider, leading, technology-driven, has its own EHR system based in California but now national, has a very simple problem. Their doctors get a ton of messages about bureaucratic things that have nothing to do with the actual health of the patient. And on top of that, whether I complain about my toe or my heart palpitations or anything else, they all just get prioritized first in, first out. As a result, the system is hugely inefficient. And the idea that in America, very expensive bodies, doctors, spend a ton of time doing really stupid things, reading messages and figuring out what's to them and what's for them and what's not, is a common problem. And so what we've built for them is a very simple system that says, we're going to separate the messages based on two things. One, all of the bureaucratic things, all the things that are not health related, we will flag and send to your operations people. And number two, for the health stuff, we will prioritize, not just based on individual conditions, so me saying I have heart palpitations, therefore it's important, but integrate that with your health record so we can understand in the context of that patient. So if I had a heart attack, heart palpitations probably means I should get urgent care. If I am a 41-year-old male like I am who's never had heart problems, then if I have heart palpitations, it's probably okay just to call me. And again, it seems prosaic, but it's hugely complicated, and it saves a lot of doctor time. Because one of the things you also see, and it turns out there's only one doctor here, but you have massive doctor burnout in America. And if you look at college campuses, when I went to Stanford, a third of the class wanted to be doctors. Now, a tenth of the class wants to be doctors. And so we're moving towards a crisis in terms of doctor efficiency and doctor availability because there's so much burnout and so much bureaucracy. Another case study, and again, this is to show that language data is ubiquitous. This is a very prosaic problem for a big pharmaceutical company. They're trying to figure out whether a patient or why a patient switches from one drug to another. And the traditional way that companies do it, is there anyone here who works or has worked in a pharmaceutical company? The traditional way to do it is to use what's used to be called IMS data, now it's called IQVIA, I think, where you look at prescriptions retrospectively, and you say, in this zip code, our prescription numbers are going down, so we're losing doctors. But that's useless in two ways. One, it's ex post facto, and two, there's no causality. There's no explanation of why. And so what these guys want to do is they want to take notes from their marketing professionals, their sales professionals, and patients and doctors calling in with complaints to understand if I am on a multiple sclerosis drug or a diabetes drug, in this particular case it was both of those, why am I switching from one drug to another? But the real dream here, and this is the dream of people like Scott Gottlieb, who just stepped down as the head of the FDA, is that a lot of drugs in the real world don't work the way they work in a clinical trial. Because in a clinical trial, I can select the patients and I can enforce compliance. And if you could figure out two things, one, how a drug really performs in the real world relative to its competitors, and why someone should be on this drug versus another drug, and you could identify pockets of patients in a disease state that don't have drugs that work well for them, that you could be far more effective in investing in R&D and in understanding where to devote your marketing dollars as a pharmaceutical company, but in a way that's good for the patient. But again, all this customer had was structured data, and then they moved it towards using unstructured data. And then the last one, actually, let me go back. Yep, the last one I'll use is understanding why HIV patients drop out of care. So this is another absurd problem in American healthcare. 50% of people who have HIV, who have been given a drug, and that drug is paid for, do not take their medication. And it's, again, HIV is unique in that we know the medications work. We know that the chances that you will suffer, in fact, if you take the medications, your life expectancy is exactly the same as though you didn't have HIV. But there's a wide variety of reasons why people don't take their medications. And there's rules of thumb that people use. So if you're a young black MSM, and MSM means a male who has sex with males, but you don't identify as a homosexual, your percentage probability of taking that drug is almost zero. And they basically write you off. They assume that, well, there's nothing we can do about it, so we'll give you the drug and we hope for the best. But the problem with HIV, besides the fact that that's very dangerous for that patient, you continue having intercourse, using drugs, interacting with people, and spreading the disease. It devastates certain communities disproportionately. But what we try to do is use the unstructured data, the language data, to try and understand the subtleties of what makes particular patients more or less likely to stay in care. And you find certain really interesting things. You find that patients who have mental health issues are far more likely not to take their medicine. You know that you can address those issues by sending them to a counselor, by trying to intervene, at the very least to identify who those patients are. You can put them on an HIV drug that's injectable, that you can use every 6 weeks, rather than having them take a drug every day, which you know they won't take. And you can dramatically increase the percentage probability they'll take their drugs. Similarly, and this is counterintuitive, patients who fall into that category, who see fancy doctors at campuses like UCSF and Stanford and elsewhere, do worse than patients who don't. In part, they feel uncomfortable in those campuses. In part, there's a lot of homophobia in some of those communities. And the association is if you're going to Stanford for something, you must have HIV, therefore you're a homosexual, and therefore there's a stigma associated with it in that community. So training a local clinic to treat you is much more effective than sending you to a fancy doctor at a fancy campus. And all of that data is purely in the unstructured information. And we did a comparative study, and this is now published. And here I can reveal our client here was Vive, because we've published together with them. They're a GSK division that does HIV drugs. What's really interesting here is that you get more predictive power just with the unstructured data than with the structured data. Of course, combining the two is always the best, because all of the nuances about your family structure, the type of doctor you see, whether you have mental health issues, whether you're suffering from you can't pay for the drug because you've run out of money, or you have transportation issues and you can't get to a pharmacy, all of that information is captured in this type of unstructured data. So before I talk briefly about the technology platform, because to be very honest, I don't know enough about technology to really give you a good overview, it's really important to understand, sort of to tie this all together, that we have all of this data. It's being captured at scale. That data is easier to integrate than any other type of data, because even in very crappy systems that don't talk to each other, text is text. And pulling it out and putting it in one big bucket is much easier than trying to figure out different categories for structured data. And you can dramatically impact outcomes for patients. And I'll leave you with one last thought. When you read the papers, what the papers like to write about in healthcare is the sexy new drug, the sexy new glioblastoma trial that increased life expectancy by 15 days, or failed. They love when those things fail. Or the sexy new, I'm sure you all read about this bone transplant for HIV patients that ended up curing a patient or two. But those things are largely irrelevant. And they're irrelevant for two reasons. One, because very few people, thank God, have those diseases. Number two, in the HIV case, we have medications that work plenty well. And number three, because we end up spending billions of dollars with very little return. Of course we have to do it, but most Americans suffer from heart failure, diabetes, badly redone joints, the fact that they can't get enough healthy food and therefore all of the other things in their health system get worse. Those are the things that really hurt Americans, and all of that data is there. We know what to do if we knew why you were suffering. And I'll give you one last example. We had a patient in one of our systems that we analyzed who's obese, and they were a candidate for bariatric surgery, but they also needed a knee replacement. The knee replacement doctor, the orthopedic surgeon, refused to do a knee replacement surgery for one very good reason, which is it's pointless to do it while you're obese because it never takes. You can't do the therapy. But the bariatric surgeons refuse to do the bariatric surgery because insurance makes you spend a year trying to diet before they'll pay for a bariatric surgery, which is stomach stapling. And everyone knows that those diets are bullshit, that you will never, if you're 300 pounds, lose weight by eating a little bit less sugar. In the meantime, the patient got depressed because they're suffering from knee pain, they're on opioids now, they have mental health issues, and it's a downward cycle. And to begin with, I don't know that specific patient, but I guarantee you that patient is also from a lower socioeconomic strata of society, so they're suffering in 5 other ways. That's the patient we can help very easily, where we can say, it's cheaper to give you the bariatric surgery up front. We need to make sure that we actually pay for some decent, healthy food for you. We need to make sure that we have a therapist who comes and works with you after the knee surgery. And in the grand scheme of things, you will cost us a fraction of what you've cost us before. Now, last thing I have to do this, otherwise the Amazon people will get upset with me. This is what the platform looks like. I think the most important thing to know about Roam is we work with Amazon very happily. They've created a HIPAA-compliant cloud upon which we live. I'll be honest, if our clients choose other cloud providers, we work with them just as happily, so it doesn't matter for us. But for our own stuff, we put it on Amazon. And it's pretty obvious that without cloud providers who have HIPAA-compliant clouds, we couldn't exist as a company. And our dream is that whoever the cloud provider is for one of our clients, they do the sort of the data storage, but the analytics and all of the sophisticated things I just talked about are done with Rome. I think I'm right on the dot, if I'm not mistaken. And let me turn it over to Kyle. We're going to do a Q&A at the end together, if that's OK. Thank you.
Thanks, Alex. I have one. Yep. OK. Hi, everyone can hear me, it sounds like. My name is Kyle Johnson. I'm a data scientist manager with the Machine Learning Solutions Lab at AWS, and I lead the healthcare and life sciences portion of our team. So we're a machine learning consultancy that works with customers with their data in their AWS stacks to help them solve their machine learning problems. Again, I work with the healthcare portion of our group. And then I'm also an adjunct professor at Carnegie Mellon University, where I teach a deep learning class and an applied data science class. Today I'll talk with you about, very quickly, the AWS machine learning stack so that you can understand how our natural language processing services fit within common data science workflows for natural language processing. I'll show, and then really the common data science workflow is data annotation, train the model, deploy the model, make sure it's working, and monetize it and make it useful to other folks. So I'll show you really, essentially, if you are doing a natural language processing project, Rome has this incredible platform that Alex just walked you through for clinical use cases. But not all of you here are doing natural language processing with clinical data. And if you'd like to do something maybe similar or complementary, I'll give you a walkthrough of the natural language processing tools that we offer that you can do some of this on your own. So I think most of you will have seen this before, but it's the three large groupings of AWS machine learning services that we offer. At the highest level, these are APIs that we have trained and made available to you. We've trained on our own data, trained a model, and then made that available through an API. And these are tools like a translation service, a transcription service where you can give it a voice file and we'll give you a text file back. A recognition where you can upload a picture and we'll tell you what common objects are in it. Who is in this photo? Do we have any other photos of this person? Chatbots, forecasting, things like that. For Alex's team at Rome, what they've done is they've used the bottom level of our stack. They have Stanford PhDs, really incredibly smart people that are doing very detailed work, custom work. The AI services at the top are made for folks that maybe don't have as much machine learning experience or want to work quickly on prototypes. And then in the middle is SageMaker, where you'd like a little bit more control, but also more a managed experience where we'll provide the Jupyter Notebook for you, we'll provide the infrastructure, we'll help you spin up a cluster when you're training a model and spin it back down for you. But those are the three main levels of our stack. And for folks that aren't as experienced with machine learning, or want to do some of this on their own, we offer these higher level services for you to get started more quickly. So as I said before, the common data science workflow is that you take a data set, you label it. Labeling is difficult, it takes time, it takes money, it takes a large amount of people. And then once you have the data labeled in the way that you want, you train the model using that data, you make sure that it worked, you try various different options for the architecture of your model, various feature engineering processes to get that data ready. And then you deploy that model to production, which is very difficult because it's a different skill set. Really, typically you have a data scientist train the model, and then an application services team or a DevOps person or a software engineer takes that model, that R model, that Python pickle file, whatever it is, and deploys that to a container or to some server. And then you start sending data to that server to make predictions. And then you have to auto-scale it. You have to do it in batch mode. It's a different skill set than the person who trained the model originally. And then you monitor that model. You make sure it's still working. You make sure it's still accurate. And you retrain it and repeat this process once you're no longer satisfied with the model that you have. Okay? So what I'll walk you through now is, again, tools that AWS offers to help speed up this process, this common data science workflow for natural language processing projects. The first is Amazon Mechanical Turk, which I think most of you should know. It's a crowdsourcing tool to help you label data faster, to get help with data labeling. You can do a public group of labelers where you say, this is my task. I don't care who signs up for this, as long as they're doing the task correctly. You can also set criteria by which folks are eligible to participate in this labeling task. For instance, I want people of a certain demographic. I want people from a certain area. I want people with a certain background or a certain language expertise. Whatever it may be, you can set those criteria by which annotators are eligible to participate in your labeling tasks. Then we also released at reInvent last year in November a tool called SageMaker Ground Truth, which is an active labeling add-on to Mechanical Turk. And what active labeling is it says, give my annotators a subset, maybe 1% of our total data set. Give them 1% of it, and then make predictions on the remaining 99% based on what the 1% was labeled as. And then raise up the ones to next be labeled by our labelers, the ones that the model thinks is most uncertain to it. So make predictions on the whole remaining unlabeled data set, and then annotate the ones that are closest to 50%, the ones that we know the least about, label those next, and then repeat that process. And by the end, what you'll find is that you can label the whole data set much more quickly by using this active learning process. Let's label the ones that are most confusing to our model, rather than just going sequentially in series through the whole thing. So that's Mechanical Turk and Ground Truth. And the other piece of this, too, is that we make interfaces available for natural language processing data annotation so that you can get started more quickly with labeling data to do classification, named entity recognition, relationships between blocks of text, things like that. So once you have this data set and you are ready to train a model to predict things about future data that looks similarly, how do you do this? And we have two services. One is Comprehend, which is, again, at the highest level of our stack for folks that want to do really codeless custom NLP models. And with Comprehend, there's two pieces to this. One is a custom classifier, so you can say upload a group of data, and then you want to classify it in one way or another. Comprehend is a model where you can, has functionality where you can upload a data set that you have, tell Comprehend, again through an API, that you are not having to write custom code to do, train a model that can predict where this block of text should be and what category it should be. And then there's also a custom named entity recognition feature within this, in that you can say pull out portions of this text that are of categories that we care about. So tell me if you wanted to train a custom model that could detect addresses or locations or something like that, you can train a custom model based on the data that you annotated to do this for you. And that's great, because you can now train custom classifiers, custom named entity recognition models without writing a piece of code. So non-data scientists, non-machine learning engineers can now start doing machine learning tasks and deploy those models into productions behind an API, all managed by Comprehend, and they never wrote one single line of code to do this. SageMaker then is if you want a little bit more control over that process, if you want more control over the architecture of your algorithm, or you want to maybe take the model that you've trained and deploy it to the edge or deploy it to some other server. SageMaker is our managed machine learning platform for you to do these similar tasks and much, much more, of course, but in a way that gives you a little bit more control over how that works. Model deployment. So once you have this model that you like and you're happy with, what do you do with it? How do you start using it? And again, this is where data science teams really need a data scientist or a statistician to train the model that we talked about in the previous step, and then a DevOps person or an engineer to actually start using that model for predictions in the real world. And we have tools, again, to help with this transition process to simplify that leap from model training to model use in production. And again, the tools are the same, Comprehend and SageMaker. So what Comprehend does is, again, once you have this model that you've trained via the Comprehend custom classifier, custom named entity recognition functionality, then you can take that model and it will give it to you either as an API where you can send streaming data to it, or spontaneous data to this API call, and it will tell you what it's predicting based on the custom model that you trained. Or you can do it in batch mode too. Batch mode is more common if you have a large data set that you're only making predictions with once a quarter, once a month, something like that, and you don't want to pay for provisioning this server that's running all the time waiting for data when you're not sending data to it all the time. So what you can do in batch mode is say, take 1 million records and run this model through all those 1 million records, and then shut down the server that's making those predictions, and you're only paying for the amount of, for seconds of compute time versus maintaining this all the time. And that's a very cloud-native way of thinking about machine learning, is let's only pay for the infrastructure that we need for making predictions and then shut everything down when we're not using it. And Comprehend makes that quite easy for you to switch between this API mode versus batch mode. And then same thing with SageMaker. Once you've trained a model in SageMaker or you've trained it on-prem and you want to use SageMaker hosting functionality, you can do the same thing. You can host that model either in batch mode or in the API mode. And it makes it very simple for you to take a model that, again, that you've trained anywhere, host it via this container management service in SageMaker, and then make predictions in batch or in streaming mode. Okay, so once you have a model in production and you're making predictions with it, again, in these two different formats, how do you make sure that it's working? How do you streamline that process from training a model to quality control in the DevOps process to say this model is one that we'd like, we're certain that it's better than the one that we currently have in production and we'd like to use this new model instead? That's what we call machine learning DevOps, is this process of a repeatable workflow in your data science teams that can be used to standardize this whole process. And I was speaking a couple of months ago at our healthcare symposium event in Boston, where there was healthcare leaders that were coming to learn about AWS tools. And we had a survey at the start of that conversation about what is the most common data science problem that you have in your data science organizations. And there were questions like, data scientists are hard to find, or we don't have enough labeled data, or it's too hard to understand what deep learning is. And the number one problem that people said that is most common to data science teams is that workflows are not standard. It's not that they had trouble finding data scientists, it's that they had really a difficult time making them work together. They had hired all these really smart people and they couldn't coordinate and standardize the process by which data science models were used. And this is really a solved problem in the software engineering space. There's great DevOps processes, scrums, things like that are pretty standard in the software engineering world that really aren't done very well yet in the data science space. So that was the number one issue that folks had at our healthcare symposium a couple months ago. And we have a number of tools that we use with SageMaker workflows or other data science workflows on AWS to help standardize this process, this common NLP workflow, so that every time your data scientists have a model that they like, they can be sure they can be sure of how they know that it's better than the previous model. They can have a standard workflow to check in that model. They can have a standard data set by which this model is tested and evaluated, send alerts to anybody on the management side or the production side that's managing when this model goes into play to send an alert for them to approve it before it goes into production. And all of that can be automated in standard code pipelines. And we have a couple tools for that. We have an ETL tool called Glue, or Redshift is our data warehouse. We also have a couple of DevOps tools. One is called Code Pipeline. And then the other really very common data science workflow orchestrator that we see lately is called AWS Step Functions, which is a Lambda orchestration tool. And then once you have this model in production, a very quickly catching on piece of SageMaker is a model marketplace that we offer, where you can take a model that you've trained and then deploy that to this SageMaker marketplace, and then other folks can search through this model marketplace and procure your model. So these are data sets just like, or these are models that customers can buy from you, and you never even have to talked to this customer. And there's hundreds of models available on there today in the SageMaker marketplace. One of the reasons that customers really love the SageMaker marketplace is that it simplifies the procurement process too. We have many customers that like doing hackathons or bake-offs with customers, or with vendors, I should say, especially smaller vendors if there's a bunch of them, maybe 10 people competing in a hackathon for some big pharmaceutical company. What the marketplace lets them do is they can have the competitors in this hackathon upload their models to the marketplace and then start using those models through the SageMaker marketplace without needing special procurement processes for each of those vendors. So it really simplifies the process of buying data science knowledge from smaller vendors, and then you still get the same AWS bill, and you're buying the model from that vendor through your AWS bill. And so you don't need a separate MSA, a separate procurement process with these smaller vendors. You can do various things like free trials or a certain number of API calls to this marketplace. And it really, really simplifies the process of going from a new small vendor to making predictions in your enterprise data mart or your enterprise data science workflows. So that's, and it's also great for these smaller vendors because they now get to work with larger scale customers that maybe they never would have had access to before, because they're training a model on their own data, making it available through this marketplace that anybody in the world can see this model, test it out, and start using without ever having to do a meeting, without ever having to even have access to this larger enterprise's data set or VPN or whatever it is. And it's, I don't think something that we necessarily expected as the most value add from the marketplace, but that simplified procurement process has been incredibly useful to our customers. Now, if you want to get started with some of these ideas on your own, these are the four steps that I recommend that you try to really get started with using some of these data science tools and NLP workflows on AWS. The first is to take advantage of the free tier. We still have customers all the time asking us, okay, I'm interested in SageMaker. How do I get started with it? How much does a license cost? And AWS tools don't work that way. You can try all of these in a free tier. You can try them out and you're paid by the amount of seconds you use it rather than provisioning 20 seats through some software license that you have access to for 3 years. You can spin up the tool. You can use it for 5 minutes if you want, shut it down, and you're no longer paying for it after that. So I would take advantage of the free tier because you can try these things instantly without paying a cent for them. We also have a machine learning university within Amazon where we train developers and data scientists on the latest machine learning techniques. And what we've done is made that available for free to customers to view the Amazon.com internal content that we've made for training machine learning folks. And we've made that all available to you for free. So you can go to the Machine Learning University website within AWS.com, and you'll see how that works. The model marketplace, which I just mentioned, is a great way for you to see what other people are doing in the data science world and for you to try some of these things on your own, and also to try and monetize some of the data science work that you're doing. You can deploy SageMaker models to it and again, work with customers that you've never met face-to-face before. And the last thing I'll say is to know that you have help available. There's all these great blogs on the AWS machine learning blogs walking you through common workflows, common problems that data scientists have, how to use R in SageMaker, for instance, or how to integrate SageMaker with graph databases or SageMaker with common CI/CD processes. The AWS blogs are a really incredible resource and I think probably an underrated place to go to learn about how to do data science on AWS. And then if you're from a larger organization, the account team that is assigned to your organization has a solutions architect that can work with you, specialist solutions architects that focus on machine learning, even within verticals if you want to focus on machine learning within healthcare, machine learning within oil and gas, machine learning within finance. We have folks dedicated to help you and work with you and can speak the language of your vertical. And then there's also teams like Machine Learning Solutions Lab, where I'm a part of, that can come and do actually projects with you and actually get in your data, get in your stack, and start to help you build some of these things on your own. And with that, I will stop and then invite Alex back up so we can do Q&A. We have about 10 minutes left.